Alright, so you guys just finished up the lab Water on the Move, which is a part of our scientific approach cycle, and let's take a look at the lab. To start with, you were asked to take a pie pan, fill it up with enough water that the bottom was covered, add 3 drops of dye to it, mix it up, add a candle into the middle of the pie plate, light the candle, and then once the candle was lit, you were asked to put a beaker over the top of the candle and to see what happens, making sure that you add pressure, which you were adding pressure to the top of the beaker to make sure that this glass was firmly against the bottom of the pie plate, and to watch and see what happens. And what you started to discover happening is that this candle was very, very bright to begin with, started to get dimmer and dimmer, and eventually the candle went out. But also what happened is that during the course of this heating, you noticed that suddenly there was these like water molecules and water droplets that started to form on the inside of the beaker. And we know that when a candle is heating up in a closed space, it is going to heat up anything that's on the inside here. And so what we know is on the inside is that because we covered it up, that there are oxygen molecules that are found on the inside of the beaker. So these were getting heated up, and anytime that molecules get heated up, they start to get very, very excited. They start to get moving around, so they start making collisions with the outside of the container, in this case the beaker, and with each other. So all of a sudden there's this banging of and collision that is occurring, which is going to result in a lot of pressure on the inside here. So pressure is being created because of the collision of the oxygen molecules. But also there's some other molecules that are found inside here. Because of the fact that when you put the beaker over the top of the candle, there was some water that was on the inside. And because of this heating, some of the water molecules are going to go from the state of being a liquid into a gas. And so we're going to also start to see that there's some water that's going to be collected on the inside of the beaker, which we saw right here. And that's all due to this candle being heated up. Now, if we understand that the candle is heating up the oxygen molecules, they're putting pressure on the outsides of the container and also on one another. If we take away that heat source, so the candle goes out, we take that away, those oxygen molecules are going to come flying back towards one another and slowing down. And what it's actually going to do is it's going to create this kind of vacuum of space where they come together. And it's going to have a lot of pressure that is going to be the result, also resulting in the fact that it's going to pull the water up towards the molecules. So it's actually going to create a vacuum that's going to pull the water molecules up. Now, because of the fact that we don't have a huge, large space in there, it's not going to pull the water up and over the candle. So actually what's happening is that the water is being pulled up due to the pull or the vacuum of these molecules. I don't want to use the word suck together, but really that's what happened. The molecules came flying together, or they sucked back together, resulting in the pull of the water upward. So the reason why the water came up is because of the fact that the oxygen molecules cooled down. They came flying back together. The result of why the candle went out is going to be a part of our apply section, and actually it's going to be a question that you need to respond to after this, so I don't want to spend a lot of time talking about that. But understand that inside of here there is oxygen that is found. There's some water that is found. So that combined with one other possible thing is going to be the result of the candle going out. Which one of those? We're going to discover it in the next unit. Alright, so take a couple minutes, respond to the questions below, and we'll talk to you later.